This is chain no matter how you do it. This looks a little blurry too. I don't know if that's much better. I can either do this using quotient rule, or I can do this using product rule. It's not going to make a whole lot of difference, since the one down below it is similar. I'll do this guy using quotient rule. So I'll rewrite this guy as t over t cubed plus 1 to the 1/2. So f prime of t is, bring the denominator up, which is t cubed plus 1 to the 1/2 times the derivative, and now this is respect to t, of the numerator, minus the numerator times the derivative of the denominator, t cubed plus 1 to the 1/2, all over the denominator, t cubed plus 1 to the 1/2 squared. So my denominator is just t cubed plus 1, because 2 times 1/2, you wouldn't have to do this, but 2 times 1/2 is just 1. So this would be t cubed plus 1 to the 1/2 times the derivative of t, which is just 1, minus t times, now this is chain rule, this is 1/2 times the blob to the negative 1/2, this is cube, times the derivative of t cubed plus 1, which is 3t squared. There's all kinds of gross things you can do with that, all of which we won't do because we're not in that chapter. You can do something similar using quotient rule, and that's rewriting this guy, t minus 3 squared, and this would be product rule was 1 to the 1/2, by bringing it up. So t minus 3 squared, this is what I had to do because I could never remember quotient rule, t plus 1 to the negative 1/2. Now this is product rule. This is product chain. Now I could have done it using quotient rule. It would be quotient change. Either way. So g prime of t equals the derivative of the first of t minus 3 squared times the second, t plus 1 to the negative 1/2, plus the first, t minus 3 squared times the derivative, and this should be with respect to t, of the second, which is t plus 1 to the negative 1/2. So the derivative of t minus 3 squared is 2 times t minus 3 to the 1 times the derivative of t minus 3 times t plus 1 to the negative 1/2 plus t minus 3 squared, now times the derivative of t plus 1 to the negative 1/2 is negative 1/2, t plus 1, drop it a power, minus 2 over 2 is minus 3/2, times the derivative of t plus 1. So this is 2 times t minus 3. Derivative of t minus 3 is just 1. T plus 1 to the negative 1/2 plus t minus 3 squared times negative 1/2 times t plus 1 to the negative 3/2, and the derivative of t plus 1 is just 1. And that's using product rule. It would work. You could use product rule on this guy as well instead of quotient. Either one. Either one. This says find the equation of the line tangent to at x equal 1. So I'm going to divide my paper in half. This is for the line. And at x equal 1, g of 1, I need the y value, is 1 to the negative 2 plus 1 to the 5th. That's just 2. So my point is 1, 2. I need the slope of the tangent, and the slope of the tangent is just the derivative. So is the slope of the tangent. So now I need to find the derivative. So if g of x is equal to x to the minus 2 plus x to the 5th, then g prime of x is negative 2 x to the negative 3 plus 5x to the 4th. This is the slope of the tangent for all x in the domain of g of x. I want the slope at x equal 1, so that g prime of 1 equals negative 2 times 1 to the negative 3 plus 5 times 1 to the 4th, which is negative 2 plus 5, or 3. So now we know that y minus y1 is m times x minus x1, so that y minus 2 equals 3 times x minus 1. This is a perfectly good answer. Nothing wrong with that. It just says find the equation. Happens to be in point slope form. Slope intercept is easy enough to get. This is 3x minus 3, or y equals add to 3x minus 1.